Please welcome Pekka Ruotsalainen and Murali Kendai.
Hey, good morning, good afternoon, and good evening. I'm Pekka Ruotsalainen from Microsoft Digital Supply Chain Engineering, where I lead a team responsible PLM capability development for Microsoft hardware businesses. And with me today, I have Murali Kendai, one of our software engineering leads from our Hyderabad office in India. So today we're going to show you how Microsoft uses Aras Innovator's variant management module to manage our product variation, automate EBOM generation, and some other cool features developed on top of Aras Innovator. But first, some background. Why is Microsoft at ACE conference? Well, our journey and partnership with Aras began about 7 years ago when we started the replacement of our two legacy PLM systems. Initial go live was in 2016, and since we've done 5 successful core upgrades and dozens of internal feature releases on top of Aras Innovator. And if anyone is interested in those core upgrades, there's a separate presentation tomorrow done by our team on the upgrades themselves. So as of today, we have roughly 4,000 end users and more than 300 external partners are accessing one single Aras instance for product data for Microsoft. And this platform, which we call One PDM, is utilized by all Microsoft hardware products. And speaking of hardware products, we have 2 major business groups, Cloud and AI and Devices. So on Cloud and AI side, the Azure data centers that are running various applications in our data centers and HoloLens. And then on the Devices side, maybe more familiar products for the end users and the consumers, the Surface laptops, Surface computers, and Xbox gaming consoles, and all the various accessories associated with those products. So why variant management? Well, even though our products are not as complex as cars or airplanes, they are still highly variable, and thus we needed a tool to manage the complexity, drive efficiencies in EBOM generation by automating it, and also drive data quality. And just as an example, one global Surface product launch can result in anywhere between 1,200 to 1,700 SKUs, and managing all that manually was simply not an option. So what are the different features or aspects of variant management that we are leveraging? So I've divided that into 3 different buckets. So first is the offering management, how to capture the offering and how to digitize that. And we are doing it now in the variant management module in Aras Innovator, which actually replaced an Excel-based process, which is kind of ironic coming from the company that produces that product, but still we are replacing actually in many cases an Excel-based processes with the actual digitized tools. So this offering management, when we define that, it actually acts as a guardrail for the EBOM generation. So only the configurations that are part of the offering can have an engineering bill of material. And it also enforces the master data management and master data definitions when we reuse for example, the configuration definitions between different products. The main aspect, obviously, for the variant management is automating the BOM generation, and we've done that especially for the Devices business where the volumes are quite huge. So it's 100% automated, repeatable BOM generation process, no more manual BOM generations happening for the Devices. We've also built some pretty efficient BOM validation tools to validate the BOM completeness. No more parts missing. Every single deployment BOM is 100% BOM based on the architecture that has been defined, and we can also track the readiness of the design when we in the R&D cycles. With the super BOM concept, we are also centralizing the change management, and it's effectivity controlled. So no more changes on the individual BOMs. All the changes are occurring on the one single super BOM that then those changes are rolled out in the actual deployment BOMs. And once again, this drives consistency. So part attribution is automated, classification of parts, and also the part descriptions are automated based on the metadata that is born in this VM process. And the last piece is kind of relatively new to us. In this variant management process, this configuration data is actually a sort of a new data set that we can leverage. And we can, for example, link the different BOM levels. We don't have to do like a complex where used queries to link the devices to the higher level localized devices that then gets linked to the SKUs. We can do that automatically based on this configuration data. And we can also leverage that in several other processes, and we will show at least one demo of that later in the presentation. So let's go through the high level. So this is 50,000 foot level process definition for how to leverage VM, and this is coming from our devices organization. So the first step is to obviously to capture the variability and capture the various aspects of the product. So in our world, we start with the offering definition. It's done with the sort of a straw BOM concept that captures the main architecture of the product and defines the proliferation points and captures the variability and then captures the offering as well. And then we finalize the super BOM with the specifics of the device BOM, whether it's like a computer or tablet or any other product. Even key sets are defined in this way. And to finalize the SKU definition, there's accessories, power supplies, power cords, sometimes pens, mouse, anything that goes into the SKU packaging or the SKU pack, and then the various printed materials, and finally the packaging on top of that. Once that is completed, we can do validations, and then obviously the BOM generation when the super BOM is completed. And the final step is how this data gets consumed downstream. So bill of materials, obviously business as usual. We send that to sourcing and planning, and also to the contract manufacturers. But now this new data set, this configuration data, we can leverage that in new areas such as sales and marketing. So let's take a look at least my slide is not loading. Okay, there we go. So how to digitize offering. So this is a high-level illustration from our world how the offering gets captured. So we start with this sort of a high-level straw BOM that captures the proliferation points, and those proliferation points are there marked on the red color. So on the software, you see localization with the software area. There's different Office packages, OS packages, localization for Wi-Fi, localization for TPMs, etc. And then on the hardware device itself, processor, memory, storage, TPM, color, other different variation points. And then when we define the actual offering, we set rules between these different proliferation points. This is typically the starting point to capture all that. So this comes from the marketing and engineering together. They define what we call POR, plan of record, that captures the sort of a different variation points for a new product. So in this case, we have different screen sizes, we have different colors, different processors, memories, storages, different key sets. This seems to have a fixed key sets on the product, so those has to be captured. So based on this document, we then build rules. So once the BOM architecture has been captured and the proliferation points has been captured, then we go into building rules. We have 3 sets of rules. First one being the technical. So different CPUs, processors get a different memory configurations. So for example, CPU, if CPU is i5, the memory can be only 4 or 8. If you get a higher end CPU, you get a bigger memory, 8 or 16. Then we go into localization. For example, the power cord obviously has to be localized. So if the market area is US Canada, you get a US power cord. If you go to Nordics, the power cord is the European one. And then on the device itself, for example, TPM is localized. The Chinese get their own TPM chip from the rest of the world. And then when we go to the SKU level, we have our sales and marketing rules. And in our world, for example, this always is divided by segments. So if the segment is commercial, you get a Win10 Pro, and if the segment is consumer, you get a Win10 Home. And the end result in Aras Innovator, it looks something like this. So this is the graphical interface or the graphical representation of those allowable configurations. So every one of these swim lanes is allowable configuration, SKU configuration. And this can be then obviously consumed outside of PDM system as well. And in our world, this goes to, for example, marketing and marketing or sales and marketing. They do the launch wave planning and also the pricing of these SKUs. And next we have a demo. So please queue up the demo. First demo, please.
We will see a demo of product offering using variant management. This is a super BOM at SKU level, top level product hierarchy. These are the components in the super BOM like regional device, the power cord, the power supply unit, and all the sub packaging assembly. Similarly, I can define at regional device the vanilla hardware and the software that goes in the hardware. This is how the super BOM is constructed. For each of the V component, profilators are offering details like market area, the SKU type is defined. For example, for a vanilla device, it can be a processor, memory, storage, or color. In this case, the black or platinum helps to create the variant of the product. Once the product offering is defined, then we can define some of the business conditions that can be related to the technical or sales and marketing or any other competencies. For here in this case, a vanilla device with processor i3 can have only 8 gig memory and 128 GB. So I can define all these rules which are effectivity control, and once I define that, the profilators and offerings and the options along with the rules, I can see the entire product offering in variant tree. The entire product offering is completely digitized. Instead of multiple spreadsheets with different revisions residing in across various discipline teams like marketing, planning, and engineering, now everything is at one place.
Okay, thank you, Morley. Let's go to the next section, which is the automated BOM generation. So this is the next step. When the super BOM has been completed, we can do the validations and then eventually generate the engineering bill of materials. And we go slightly in a wrong order here, but I'm going to show the logic of BOM generation first, and then Murli will have a demo on the BOM validation. So let's get started. So highly simplified super BOM on the left-hand side, and the offering definition there on the top. So those 3 lines are the allowable configurations that we can do out of this super BOM. And when we generate the BOM, obviously we pick a configuration there, and then the system will generate the BOM for that configuration. So starting from the bottom, the software assembly based on the OS, Office, and Wi-Fi region settings, it pulls the correct parts into a bill of material, and it pulls a new part number for that. And obviously it classifies, it puts the metadata in place, etc., so that the part is complete. It's basically ready for release. And the next layer adds CPU, memory, storage, color into the mix, and builds the next layer. So it pulls the correct vanilla part there, and then attaches that next to the software assembly under this regionalized device. And once again, pulls a new part number for that. And then finally, at the SKU level, it adds SKU type, market area, segment into the mix, pulls correct PSU and power cord parts into the bill of material, and then the bill of material is complete. And obviously, we are not doing this one by one. We have created efficient way of doing batch processing, so you can select like a 200 to 500 bill of materials, or actually configurations, and just batch process them, generate the bill of materials as a batch. So not doing those one by one, obviously. And we have a demo on the BOM validation. So there's a few ways of validating the bill of materials. So what we call BOM scrub, which used to do a process where the configuration management team would actually generate a few dozens of BOMs, and then they would sit down in a meeting, go through those different variations of the bill of materials one by one, and validate if the BOMs are correct. No longer needed. So we can validate the super BOM at one go, and everything, basically all the variations will be validated at the same time. And then there's 100% validation, which is now done by the system itself. So if based on the architecture, if it expects to get for example, power cord and it's missing, it won't even generate the bill of material. So there's this 100% validation embedded into the tool. So cue up the video. Thank you.
Engineering BOM generation has been completely automated using product offering and variant management. This is the SKU super BOM structure with various components. To create a BOM with the different teams like packaging, software assembly team, and configuration management team come together to scrub the data. For a vanilla device, these are the different vanilla parts. So they just validate whether the part is mapped with the correct configuration. In this case, let's say it's an i5 16 GB hardware device, so it's mapped to the proper configuration. Similarly, I can see for a software assembly whether it has proper OS version and particular region. So I can completely validate the whole BOM for each of the part. Once I validate, it shows if there are any issues. In this case, it shows red because of some issue in the packaging assembly. I can go and drill down. It's on one of the subassembly. These are the configurations which doesn't have the part. So the packaging team has to create the parts and need to be attached to these configurations. So once it's attached, I can generate the BOM even for one configuration for all the configuration in batch.
Okay. The next and the last section is the configuration data. How do we leverage that? So it's the last step of the process. How do we consume this data outside of our PDM system, and what can we do with that? So to explain this configuration data, this is once again a bit simplified illustration of that. But when we generate these different layers or different levels of the bill of material, in our world, the top level is always a SKU. Typically underneath that there's a regionalized device, and underneath that there's a vanilla device, which is purely the hardware of the product. And when we generate these from VM, this configuration data gets attached to the resulting part. It's basically a recipe out of which that bill of material was born from. So starting from the bottom, vanilla device, there's a CPU, memory, storage, TPM, a key set, country of origin, code name, and color. That data set gets attached to the resulting part. And the next layer, it adds a few parameters, so device area, OS, and Office, and that gets attached to the next layer. And then on the top, there's a SKU type, market area, segment, plug type, and PSU, but they share the rest of the parameters. And with this data, we can build, for example, this kind of relationships. I'm waiting it for to load. At least I'm not seeing it. Okay, now I can see it. So these kind of relationships between the different layers. And what this does is that we can send this for the forward and reverse logistics when they plan the volumes. So typically we plan the volumes on the SKU level, but now that can easily be translated into volumes on the lower level items. So when we try to produce these SKU amounts, it gets translated into regionalized device amounts, and that gets translated into the same vanilla. The same vanilla is leveraged by by all these 6 different SKUs. And the same applies for the reverse logistics. When a customer sends back, for example, the A SKU, well, they don't send the full SKU back. They actually send us back the regionalized device, which get then repaired as a vanilla, and that repaired vanilla gets a different part number. And we can build these links automatically now based on this configuration data. And this helps enormously in figuring out these volumes and building these connections. The last use case or last sort of demo we're going to present is our dynamic labeling. So once again, what used to be an Excel-based, manual Excel-based process is now replaced by this digitized VM-based process. So on the left-hand side is the sample of that Excel, which was manually created. Every single SKU, sometimes 1,500 lines of Excel manually created, and those dynamic text values individually assigned for every single SKU. There on the bottom, you see a sample of those labels that you find out when you go and buy your Surface device. You find this kind of a label on the SKU box. So it calls out the hardware configuration, what is the processor, memory, storage, sometimes color, country of origin, etc. And it can be also localized. So there's some localized values. What we do today in the VM process is that we build a label assembly. So we have those templates there that are all the template itself is proliferated. So different different labels for A SKUs and exchange, commercial, consumer. That's quite typical way of proliferating them. But then we have those dynamic values that are based on the configuration of the device itself. And when we generate the bill of material, this label gets generated as well, and it's 100% matching, obviously, the configuration on the top. So we see the correct CPU values, memory values, storage values, color values that is based on the product itself. This used to be a huge issue in our first article inspections when the label and the actual device didn't match. Obviously, that is a showstopper for any SKU leaving the factory. So no more of those first article inspection failures because of this. And that concludes our presentation for VM. Before we jump into Q&A, I just want to briefly do some like a quick remarks on this journey. So we started this like roughly 2.5 years ago. It took us a while to get here where we are today. We've done a ton of customizations on top of Aras platform, but we are obviously still leveraging the core variant management capabilities from Aras, but definitely a lot of customization. For example, this automated batch processing and some of the validation capabilities have been customized for our needs. But so far this journey has been really successful. So we've onboarded both of our hardware units, so cloud and AI and devices into leveraging this VM process, and there's a commitment for our next fiscal year, which starts in July, to go 100% on VM. So it's been a successful journey, and if you have any technical questions, so Murli is here to moderate the Q&A. So let's move to Q&A.
Thanks, Pekka, for the session. We have a lot of questions. So I'll start with the first question. Nations do you manage? I think as Pekka said, for the devices, it varies from 1,200 combinations and it goes up to 4,000 combinations. So it depends on the product, but roughly it goes from 1,200 to 4,000. So, and Pekka, do you want to answer this? Do you have a part number per variant configuration? The question
All
is,
the unique,
yeah,
yeah,
right,
all the unique configurations will have their own part number. Yes.
right. Okay, and there's a question from Alexei actually. Do you distinguish between technical and localization sales rules? Yeah, right. We have seen in demo and also Pekka explained it. So we can categorize or classify the rules. Either it's a technical, for example, if it is a i3 processor, then I can have only 8 gig kind of thing. Similarly, for a localization, if it is a US, then the power supply unit has to be US power card. So like that, we can have the rules defined, which can be either technical or localization. So that's
Yeah.
on this way.
Everything is done in Aras, so they are not done on the authoring tools such as CAT tools. Everything is done in Aras.
Right. Okay, so there is another question. How obsolescence is managed in your scope?
I'm not sure if I know the term. If that is like if there's a missing, is that a missing part or something? I don't know the term. Sorry.
I mean, I think is it it's driven through the effectivity control because whether your families are an option, so we have an effectivity control, and does it? I think that's what they mean it obsolescence, but I'm not sure what Oliver is referring to here.
Hmm.
Okay, moving on to the next question. Aras VM is still in sample. Is it what you're using as baseline? Yeah, we are, as Pekka said, actually, we are using the VM core engine for our resolution and things. But on top of that, we have done a lot of customization. Maybe when you're seeing the way the bomb is configured or the super bomb is configured or the rules is defined, all those are custom development, which we are trying to replace that with the Aras out of the box once we have the VM in production. Okay. Do you create this matrices in Excel and then upload them to Aras via connector?
No, we don't. We do
Yeah.
have some Excel import capabilities, for example, for part usages and when we bring, for example, the marketing data into our PDM system, but the main modeling is done in Aras UI itself.
Okay. And there's one more question. Are you planning to use the variant rules to manage structures other than the super bomb?
Well, so far our scope has been on the engineering bill of materials. So if we someday plan to expand to, for example, requirements management, we might want to leverage the variant management module also in the requirements engineering space. But so far no plans for expanding that direction.
Okay. And we have a last question actually. Do you resolve the super bomb in Aras and transfer each resolve variant to ERP solution? Yes, we resolve the super bomb in Aras, and only the 100% bomb is transferred to our in-house ERP system. Okay, I think most of the question is answered. I think we have covered the questions, Pekka. Yeah.
If you have any questions popping up after the session, feel free to contact us directly or contact your Aras representative, and they can forward the questions to us. So, but thank you for the session.
Thank you all.